Alright guys, welcome back to another fun-filled, action-packed, flipped geometry classroom video. Today's topic is the Pythagorean Theorem. And if this sounds familiar, that's because you've learned it before. It's review. We're still reviewing. You're not learning anything new yet, technically, unless you didn't learn it for some reason. But anyways, let's get started with these notes. Right now. Wait, where's the start of these? Where's the start of these notes? Okay, here we go. Alright, so there's a bunch of blanks here. Now check this out. Waka! Look at all the things have been filled in, so let's just read this together. A and B are called the legs of the triangle. C is the hypotenuse, just kidding, it's hypotenuse. Hypotenuse of the right triangle. It is always across from the right angle, and it is the longest side in the triangle. So take a look at our picture here. Which side is the longest side of the triangle? That would be C over here, and that's called the hypotenuse. And with that, we're going to jump into some examples of how you would use this. Remember, this is over the Pythagorean Theorem, which is written right here. A squared plus B squared equals C squared. How do we use this to find stuff? Check this out. In the middle of our page, you will find the first example. Look at this triangle with the sides 6, 8, and C. I need to find the length of C, but I don't know what it is, so that's why I'm trying to find it. That was redundant. So you're going to use the Pythagorean theorem. A squared plus B squared equals C squared. Now we're just going to fill in the blank here. A is, doesn't matter which side we pick as A. I'm just going to say this side over here is A. And I'm going to say this side over here is B. Now I'm just going to plug it in. So we've got 6. That looks dirty. 6 squared plus 8 squared equals C squared, because we don't know what C is yet. All right, now what's 6 squared? Put that in the calculator, or just know how to square stuff. 36 plus what's 8 squared? That's 64 equals, well, what's 36 plus 64? First of all, we have C squared, but we actually know what this number is right here, 100, when we add it together, and that equals C squared. Now, am I looking for C squared? Does this side say C squared? No, this side says C, so I need to get rid of the squared sign right here. How would I do that? How do you figure I would do that? I take the square root of both sides, and that would give me that C equals 10. Now, technically, that would be plus or minus 10, remember? But since we're looking for the length of a side, it's not going to be a negative length. That just makes no sense. All right, so it's going to be 10 equals C. So that's how you use the Pythagorean theorem. Boom. Let's try another one, shall we? Let's go to the next example over here with sides 7, 25, and B. This is a different order. As you can see, they gave us the hypotenuse, C. So let's use our formula again. A squared plus B squared equals C squared. And the side B is labeled for me, and I know 25 is C because that's the longest side. And so that means this side over here, 7, has to be A. Let's just substitute our values in now. A squared, A is 7, so 7 squared, plus B squared, I don't know what B is, equals C squared. C is 25, so 25 squared. What's 7 squared? 49, beat ya. Plus B squared equals, what's 25 squared? 625, I know that one. And now I'm going to solve to find B squared. So I'm going to subtract 49 from both sides using basic algebra. I'm going to find what B is. I don't know why I said B squared. 49, subtract that from both sides. B squared then is going to equal 576. And am I looking for B squared? No, I'm looking for B. So I got to get rid of the squared sign. What do? I take the square root of both sides, and that leaves me with B equals 24. 24 is in fact the square root of 576. You can use a calculator to find that, or you can know it in your head, like I definitely did there. So B is 24. So this is 24. So that's how you use the Pythagorean theorem to find missing sides. You set it up, you write it out there, you substitute the sides that you do know, and then you solve for your missing side. Now let's take a look at some common Pythagorean triples. And let me show you some common Pythagorean triples here. All right, first of all, you've got the classic, everyone's fan favorite, the bread and butter. You've got the 3, 4, 5 right triangle. 3, 4, 5. Next up in second place, you know, a lot of people still like this. A lot of people still like this one. This is gonna be the old 5, 12, 13 right triangle. And then another common Pythagorean triple. You know, this is more for those underground right triangle fans. The ones, it's not so mainstream yet, but the 7, 24, 25 is another one of those common Pythagorean triples. So these are common side lengths for right triangles, and you can actually find a bunch of different lengths for triangles by doing this. Because look, you got the 3, 4, 5, right? You got the 3, 4, 5. You also have, like I said, the 5, 12, 13. And then last but not least, you got the 7, 24, 25. Now there's other ones, but these are just 3 very common ones. And we can find a whole bunch of common Pythagorean triples by multiplying these numbers by 2, by 3, by 4, by 5. And that would give me a bunch of different combinations. You see, if I multiplied these by 2, I would get the 6, 8, and 10 triangle that you saw earlier on this page. If I multiplied the second one by 2, I get the 10, 24, 26. And if I multiply the third one, I get the 14, 48, 50 triangle. So, as you can see, there's going to be a bunch of different combinations, and I want you to fill in this chart, and that's going to be the end of these notes. Wow, that was pretty quick. So, that's the end. See you in the next one. Peace.